This week on the show, we have the OpenBSD 6.7 on PC engines for you. We do a bit more NetBSD code studying, going very deep. DRM updates on OpenBSD are about, and a booting FreeBSD on HPE Microserver SATA port tutorial for you, with a 3-ways multi-boot OpenBSD boot tutorial of sorts, and more in this week's episode of BSD Now. BSD Now, episode 357, Study the Code, recorded for the 1st of July 2020. This episode of BSD Now is brought to you by Tarsnap, the online backup for truly paranoid people and normal people. Head over to tarsnap.com for more. Hi, I'm your host, Benedikt Kreusling.
And I'm Alan Jude.
Welcome to this week's episode. We have some interesting news as always for you. And the first of those is OpenBSD 6.7 on PC engines, APU 4D4.
Yep, so this goes. I just got myself a new PC Engines APU 44. I miss having an OpenBSD box providing my home services. It's quite simple to install and run OpenBSD on this machine. We can even update the BIOS from within OpenBSD. So looking at the hardware, I purchased the APU 4D4, which has 4 gigabytes of memory. They bought a 120 gig TLC King Fast SATA SSD for it, a blue heat conductive pad for the cooler, a heat spreader with a placement template, the enclosure case that has LAN and is black and has USB ports and so on, 12 volt, 2 amp Euro IT equipment power supply, and the adapter for USB to DB9F for the serial port. And so they have a picture of it here, complete with the RunBSD sticker.
Nice.
So once the system is assembled, plug in the cables, Ethernet, power, etc. And if you fancy, you can decorate the enclosure with a RunBSD sticker. Then you need to install OpenBSD. The following steps were done using my ThinkPad X260, which is running OpenBSD. If you're using a different OS, the steps might be slightly different. But they used the FTP client on OpenBSD, which is also an HTTPS client, to download the install67.fs image and DD'd that to a USB stick. Then they plugged the USB stick into the laptop, or moved it from the laptop and plugged it into the APU4, connected the serial console to the laptop, figured out what the device is, and used CU to bring it up. And then when they powered it up, they could see the APU booting, and they could hit F10, select to boot from the USB drive, and tell the bootloader to use the serial console.
Ah, cool.
So they did that, booted off their USB stick, set up the serial console so that they'd be able to see after they booted the system. And you can see it's coming up with OpenBSD 6.7 RAM disk. They reconfigured the console speed so that they'll be able to go. And then the only surprising thing I noted is that I went for a whole disk GPT disk configuration. The installer told me that an EFI/GPT disk may not boot. Are you sure you want to proceed? So I answered no and went back with a whole disk Mbr configuration. When the installer is finished, I halted the system, removed the USB stick, and booted the APU off its internal disk. I kept the console connected to keep an eye on that process, but everything went okay without any user interaction at all. And so now access is available via SSH or via that serial console. Then they needed to update the BIOS. So the official PC Engine's how-to guide recommends using TinyCore, which comes with a tool called FlashROM. I had a look at it, but abandoned soon when I realized that FlashROM is just available in OpenBSD ports. So from the console or using SSH, grant access to a shell on the APU and just install FlashROM from package_add. Then you can grab the correct ROM for your hardware and install it. So they rebooted into single user mode and ran FlashROM to update the BIOS, rebooted, and then they came up with the new BIOS.
Ah, yes, there we go.
Then they provide the helpful tip for those that might be using the serial console for the first time, how to exit CU, the console utility. So it's tilde dot on its own line. In case you're interested, he also posted the full D message from the machine over at the New York City BSD user group's D message collection. He also notes that APMD works in adjustment mode, and the temperature while idling at 600 megahertz seems to be about 55 degrees Celsius.
Oh, yeah. So it's always interesting to see what kind of devices get BSD-ified, if that's the word. Very nice. And people can follow this up on their own PC engines. And yeah, good luck with that little setup, whatever you might use it for. Then next, the namesake of our episode, NetBSD code study. It's a long document, but nevertheless interesting. So they have done, as you might imagine, NetBSD, a little code study here in the booting section. They have a little introduction on how booting works, and they link to a FreeBSD book, which is chapter 2. I think that's the fairly familiar FreeBSD book. But the flow of the boot process is easy part first, turn the computer on. Second, BIOS loads mbr.s to memory. Third, mbr.s loads pbr.s from the beginning of the NetBSD partition. And fourth, pbr.s loads sector first from disk. There's a little to do here that does describe this stuff in terms of bootstrap programs, primary, secondary, and zero, but the document is already very detailed, so they skipped that or haven't done that yet. There's a couple of useful man pages to get into more details. Install boot, disk label, fdisk, and boot. And further down, they describe the Mbr structure, how many bytes are used for the bootstrap code area or the boot signature.
Yeah, so like if you're familiar with it, Mbr is the very first sector of the disk, so it's 512 bytes, and that has all the code that's responsible for starting up the computer. Starting up the OS part. Now, obviously, that's why mostly what it does is read another 512 bytes from somewhere else, which then maybe reads more code from somewhere else. But then you realize it also has to contain the partition table, which is 64 bytes, 4 slots of 16 bytes each, and a signature. So that means there's only 446 bytes of assembly code responsible for figuring this out. One of the things that assembly code has to do is read and understand that partition table. So your partition table can have 4 parts in it, right? There are 4 different partitions. So it has to have the logic to decide which of those 4 to boot, which part of that can be a flag. If you see in the next one, they mention that there's a specific bit there that marks, which partition is active or whatever. But, all the logic for that has to live there. Now, it gets even more complicated when you have a GPT partition table, because that partition table can be bigger and it's more complicated, but the code to start still has to live in that 446 bytes.
Mm-hmm.
And that's how you end up with, you boot a 512 byte binary that's actually only 446 bytes, and it reads another 512 bytes from the partition, which then maybe reads data from the disk. So if you have a UFS formatted disk on FreeBSD, the first 15 sectors, so that's like 7.5 kilobytes, have the next stage that comes after the MBR and the partition, the master boot record and the partition boot record. You then have the beginning of the file system has a reserve space for 15 sectors, which has enough code assembly in it that it actually, mostly C actually, but that can read and understand a UFS file system to find the loader or the kernel, load it into memory, and run it. And then if you've ever looked at the way FreeBSD boots, we don't have one mbr.s. We have like 4. There's one of them that lets you use the F keys to select partition 1, 2, 3, or 4 to boot from. And remember which one you did last time. And then there's one that's hard-coded to output that same menu, but on a serial port. Because if you try to write to a serial port that's not there, it can hang the system, so it had to be an optional another one. So there's a whole bunch of different versions of this too.
Oh yeah, that's why it's called bootstrapping, because you pull yourself out of the swamp like Munchausen did, legendarily, in this little tiny space and boot from one to the next, until you get to the final operating system part.
When you realize how many steps you go through to boot the damn computer, you're like, wow.
Mm-hmm. Yeah, not much real estate to live in those 64 bytes of memory, but it works and has been for a long time. And that's what NetBSD describes here. And the structures, for example, for the MBR sector is described in the code, because you have to actually modify the MBR. So it's kind of good to know the sizes of these individual bits and bytes. Then they talk a little bit about the boot blocks and what they are for and what kind of values they take. And then they described very detailed with an introduction to each, the mbr.s. Further down, there is with footnotes and all that. So it's really a deep dive into the NetBSD boot code. It almost looks a bit like a paper, a scientific one. But it's not in the 2-column format that you would normally have in an academic paper or in a conference paper. But the level of detail is definitely paper or academic in quality, depth. So if you ever wanted to know how NetBSD does it, or boots, or in specifics, which part of the boot does my system currently end up not booting further, this might be a good start if you are familiar with a bit of code reading and some assembly.
If you're interested, also my HBSDCon talk from a couple of years ago about Gelly boot. The paper especially covers a lot of the initial boot steps because I had to figure that all out and figure out how to modify it to be able to support, that little bit of code that has to stand alone and be able to read the kernel or the loader suddenly needs to be able to decrypt the disk first.
Yeah.
And it gets extra complicated. And one of the things we ran into. So in GPT, we don't depend on being able to fit that in 512 bytes, or that the file system will have left us a convenient, 15 sectors at the beginning of the disk we can use or something. We get down to we needed a place. So that on FreeBSD, we actually have a FreeBSD-boot partition type. That's usually a small partition that you can stuff the code into. But the original version of PMBR says GPT is its own partition table type, but for backwards compatibility, the first sector of the disk is what's called a protective MBR. It's basically a fake MBR that says there's one big partition for the whole disk and has a certain flag set so that a BIOS that knows about GPT will be like, oh, it's actually a GPT disk, and then read that partition table instead. But a BIOS that doesn't know can just follow along and maybe actually still be able to boot anyway. And so that's backwards compatible. And it was also so that Windows 98 wouldn't be like, hey, that disk isn't partitioned because it's not a partition table type I recognize. Would you like me to format it for you and then erase your FreeBSD disk?
Oops. Where are my files?
So there's a protective MBR, and it has to do basically the same thing as the MBR, except for on FreeBSD, it searches the partition table for a partition of type FreeBSD-boot, and then reads the code from that instead of reading the PMBR from the selected partition. But the code, because you're basically running 16-bit assembly, you can't read more than 64K of data at once.
Mm-hmm.
But by the time you add all the encryption code and stuff, the code to boot ZFS off an encrypted disk turned out to be about 80 kilobytes. And now it's about 90 something. And I think in the end, it's going to be over 128K. It ends up meaning that we needed to do more. And that was a bit of assembly that was well over my head. And after much trying and begging and so on, I finally ran into Colin Percival, who managed to write some code to make it work. And that's why you can boot off a fully encrypted disk on FreeBSD now.
Oh yeah, really a team effort and a good story that you told. And there's a video, of course, on YouTube.
Yes, there's video and a paper for it. So.
Mm-hmm. And definitely check out the NetBSD code study. And I'm fairly sure there will be more in this. It probably takes time to compile all these notes and describe them the way they are, but it's definitely a good introduction to the way NetBSD makes your system boot. All right, the news roundup this week has a booting FreeBSD of the HPE Microserver Generation 8 ODD SATA port. This is over at Rubinert, which we covered in last week's episode as well. So he keeps blogging and describing his FreeBSD experiences in this case. And writes, my small home lab post last week we covered that, Generated a ton of questions and comments, most of them specific to running FreeBSD on the HPE Microserver. I'll try and answer these over the coming week. Josh Paxton emailed to ask how I got FreeBSD booting on it, given the unconventional booting limitations of the hardware. I thought I wrote about it a few years ago, but maybe it's on my proverbial draft heap. If you're impatient, the script is in my lunchbox with a separate link to that. For some background, the Generation 8 microserver has a SATA backplane for 4 LFF drives, which means, if that pop-up comes, large form factor, of course. So another SATA port intended for a slim optical drive, as you can see in the image he posted on his blog. Most of us use it for an SSD instead, so we can keep the primary drive base for storage. The problem is that extra SATA port isn't bootable when using the server in ACPI mode, if there are any other SATA drives in the system. It's the only thing about these otherwise capable boxes that drives me crazy. The first approach is to enable the onboard RAID controller, create a logical drive group consisting of just the SSD, and set it bootable. This worked with Windows Server during a brief experiment, but it kernel panics every BSD within seconds of clearing their bootloaders. I'd also prefer not having the RAID controller between me and drives I don't need. Okay, yeah, sounds good. The alternative is to install FreeBSD on the extra SSD, then install a bootloader or a USB key that, or on a USB key that you can leave attached to the internal USB port, or an external one. And after installing FreeBSD, but before restarting, drop to a shell when offered to, and assuming your new boot key, or yeah, DA1, clear whatever partitions you have first, then format it using gparts, destroy DA1, use capital F to keep everything or remove everything without a trace, and then do another gpart create -s with a GPT label and for DA1, of course. Then you install the bootloader using gpart bootcode into that, and then you assume all 4 LFF drives are populated, configure the bootloader with the 5th and hopefully SSD drive, and set as the default boot selection with boot 0 CFG. Describes the flags and some of the parameters very nicely. And there are a few different ways you could do this, but this has worked for me for years now. The main limitation here is if you add more internal drives later, you will need to update your bootloader with a revised address. If you forget to, you can always boot the FreeBSD installer and drop to a shell to update again. Chances are, though you already have all the drives populated, it's most of the point of having these little boxes. If your microserver still refuses to boot, one has, like one of mine did, attach the bootable USB key to one of the external USB 2.0 ports instead. It might just have a flaky internal port on one of mine, but it worked fine in my other one here and in the unit I keep up at my dad's place, which I just realized I forgot to add to my home lab post. Okay, so thanks to Rick van der Zweet on the FreeBSD forums for pointing this out back in 2016. I hadn't even considered this at the time. Okay, so fairly straightforward, and yeah, people know how to do this now and can find it on the internet because Ruben blogged about it, and well, people get to the information. Very nice.
Yep.
Then next we have 3 ways to multi-boot for you.
Yeah, so this is OpenBSD multiboot installation for Uefi. So multiboot installations of a BSD system with another operating system on Uefi hardware is not officially supported by any of the popular BSDs. Because of the general interest in this topic, here I would like to share my experience with running Dragonfly, OpenBSD, and Slackware Linux on a Uefi Asus laptop. The only boot manager you need is Refined. The tutorial is appended at the end of this post. I have also attached a markdown file for better readability. So installation of OpenBSD in a multi-boot on a Uefi machine. So each OS is going to reside on its own hard drive slice. The first step of setting your system for multi-boot is slicing the hard drive. In general, if you want to multi-boot multiple OSs, you need at least n+1 partitions. The extra slice is for the ESP or Uefi system partition. Of course, you have to make sure each partition is large enough for the OS that's going to reside on it. As mentioned in the tutorial, I share my experience with installing Dragonfly, OpenBSD, and Slackware Linux. I sliced the hard drive from Dragonfly, which I have exemplary description of over on their handbook. Of course, you will slice the hard drive from the first OS that you are going to install. In the above link on the Dragonfly documentation, I have also described how the ESP can be set up. Therefore, in the following, I will assume your first OS has already been installed and that Refind has been installed into that ESP, and I only consider the specifics of setting up OpenBSD. First of all, I cannot enough recommend that you read the install.amd64 documents on the FTP site for OpenBSD. Of course, this is for OpenBSD 6.7, so in the future, look at the newer version. Prepare the install media for OpenBSD as described on their download page, or the FAQ section. If you would need any for additional firmware, make sure to download it to the USB stick as well, since you might want Wi-Fi to work. And they specifically mentioned that they needed the IWM firmware. And make sure to download not only the tar files, but also the signatures so that Signify can check them. Boot the computer from the install media, give them through the questions the installer asks that are not obvious on how to answer them, install them, set it up. When it asks you which disk to install to, you can select your disk. And then when it comes to slicing, we assume we are already created a disk slice for OpenBSD from Dragonfly. Now we have to give that slice a type. And so we edit partition 2, set the type to A6 so that the OpenBSD installer is able to recognize it. So select your hard drive once offered and then select edit and go through the interactive fdisk session. Then you type P to print out and make sure it shows up correctly. And then you're good to go. As we are going to use Refind as our boot manager, you do not need to toggle a bootable flag on the OpenBSD partition. Note on subsequent installs, the OpenBSD installer detects the A6 partition and readily offers it as an OpenBSD area. So instead of using whole disk, use the OpenBSD area or edit the GPT partition table and make it the OpenBSD area.
Oh yeah, very nice.
Yep, and then I talk about using the SP and MP kernels, and importantly copying the boot x64.efi into the ESP as boot x64-openbsd.efi, so that and then you're editing the Refind config file and telling it to add in a menu entry for OpenBSD. Looks like they reused a FreeBSD entry from the example and kept the FreeBSD icon for their OpenBSD. I think it does have an OpenBSD icon included.
For the eye candy.
Yes. Oh, apparently there is no OpenBSD icon right now, but I'm sure you can fix that. And then they do their typical post-installation, like add a user and setting up X and so on. But it means that you can do it. Yes. There was a similar tutorial we covered a while ago on, I think it was Nicholas Sizing did for his X270 laptop.
Yes.
Which comes with Windows pre-installed. He shrunk the Windows partition in half, set up Refind, installed FreeBSD to the other half of that disk, and used Refind to dual boot between the built-in Windows and the FreeBSD, which I do the same thing on my laptop as well. It would be nice to get that more integrated into the FreeBSD installer, although it's a bit more complicated and is made slightly worse by the fact that Refind is GPL licensed. What's interesting about that is that the original project called Refit is BSD licensed, but was abandoned many, many years ago and eventually picked up and turned into Refind. So I think it would be too much work for someone to go back to Refit, which is BSD licensed, catch it up to today's systems to have something BSD licensed. But it'd be really nice to have something like that. But we can just do it from a package or something.
Yeah, that's possible.
Maybe when the FreeBSD installer gets rewritten, we can have an option to download the Refind package and install it and set it up with all the systems that are detected on your machine.
I'll stick around to see that happen. It would actually be nice to if someone or a couple of people will pick that up and do just that. Okay, you heard it here first. Time for the Beastie Bits this week. We have pfSense 2.4.5 release P1 is available now. And over at Netgate, of course, you find the highlights and what's new in this. They're, of course, pleased to announce the release of pfSense and are providing you with the installation images, links to that, and release notes. The highlights are security and errata. The pfSense software release addresses several security issues. Yes, addresses an issue with large PF tables causing system instability and high CPU usage during filter reload events on some multi-CPU platforms like Hyper-V and Proxmox and some bare metal systems. Always good to have that fixed as a firewall appliance. Fixed an issue as well with SSH guard, which could prevent it from protecting against brute force logins. Okay, that's fixed. And they updated the Unbound to address several CVEs, as well as JSON-C as well to address those CVEs. They added protection against misconfigured group privileges, preventing the admin account from making configuration changes. Yeah, that would be bad to keep that in, so that's fixed. And they also addressed issues with Suricata and FRR failing to start on some platforms, notably the Netgate SG1100 and those ARM64 and AArch64 architectures. Some FreeBSD security and advisories were also imported, including the IPF one, the one for libalias, the two libalias ones, by the way, and the one for CryptoDev. You can find the release or the security announcements on FreeBSD's website, and Netgate also links to that. So, okay, notable bug fixes are also, they fixed the language selection for Chinese in Taiwan and Hong Kong translations, as well as added support for Intel IWM wireless cards in client mode only at the moment, but maybe there's more in the future. Added support for QLogic 10 gigabyte Ethernet interfaces to QLX GBs, and DNS resolver eDNS buffer size for DNS flag day were also updated. Of course, there's an upgrade note. Be aware that you should proceed with caution when upgrading pfSense software while COVID-19 travel restrictions are in effect, because remote upgrades of pfSense software should be carefully considered in case you rig your system and you cannot go to it and physically unplug and reset the system. Because of the travel restriction, that might be an issue.
Yes, I know a lot of that type of maintenance has been put off. Even the data centers where some of my stuff was, it was like, yeah, you have to email ahead and create an appointment to be able to get into the data center to fix things. And please only do this for things that are dire emergencies, because just doing routine stuff should be put off.
Yeah, we're still in lockdown. Okay. Yeah, and they provide, of course, upgrading instructions and how you get to this latest version, and way to report issues and how to get to the latest versions, and of course, supporting that project. And yeah, very nice, Netgate. Congratulations to a new release, and hopefully the firewalling goes a bit smoother this way. Then we have a YouTube video for you from BSDCan 2020, which recently concluded the online conference, the first of its kind, because reasons.
Yeah, I think this is uploaded by the speaker. The BSD Cam videos aren't done being edited yet.
Okay, we'll wait for them. That's fine, because we watched this for now. Tom Smith about OpenBSD and OpenBGPD as ISP control plane. So that's already something you can watch for an hour. Don't have to wait for the rest to come. They will come, and we will announce it, of course, when they are ready. Just takes a little bit of time because it's a big conference, so it's a bit of work to get all those done. Next item, OpenBSD DRM update.
Yeah, so Jonathan Gray, who's JSG at openbsd.org, has just committed an update to the DRM code in the tree. This update brings support for the newer AMD and Intel graphics cards. So you can see the commit here from earlier in June, and updates the DRM to Linux kernel 5.7, which adds support for the Vega 20, Raven 2, Renoir, Navi 10, and Navi 14 AMD cards, and Ice Lake and Tiger Lake for Intel. Special thanks to the OpenBSD Foundation for sponsoring this work, and Katenis and Patrick for helping to make it work, and apparently also some work to adapt the Rockchip DRM code so that it'll work on some of those ARM devices as well.
Yeah, so that should get the faster pixels department moving a little bit faster. Excellent. This week's episode of BSD Now is sponsored by our friends at Tarsnap, the only secure online backup you can trust your data to. Even paranoids need backups. Yes, they should do that. Normal people, paranoids, everyone should have backups. And when was the last time you did your backup? If it was a year ago, that's very old. You should do one. And while you're doing that, you should consider using Tarsnap or taking a closer look at that, because that gives you the way to do online backups in case your machine burns down and other things happen. You can still pull it down from the secure web. Why is it secure? Because as long as you keep the key, you can download and decrypt the encrypted backup from the web. No one else can. The people who have the key, and that should only be you or trusted people that you definitely trust, are the people who can decrypt that. It's encrypted locally. Whatever you want to back up is first read and then segmented, deduplicated, so you can save a bit of storage space. Then it's compressed as well, and then it's encoded and encrypted with your personal key. And then only the encrypted stuff hits the web, which is AWS in the Tarsnap case, and no one else can make any sense of the files or what kind of file types they are, because it's all encrypted, and in case you need your backup. And you can, of course, pull it down with the key and the Tarsnap command line interface, or if you want to have a GUI, that's also available by third-party people. And that's what Tarsnap provides you with.
Yep, just don't lose the key, and then only people with the key can access the data.
Yep, you can read all about the Tarsnap design, about security implementations, flexibility, efficiency, and utility, and the open source.
And of course, the complete source code for the client. So all the software that runs on your computer, you have the source code for. So you can make sure that it's encrypting your data with your key and no other key before it leaves your machine.
Yep. And if your psychiatrist still says has trust issues, then look at the code and figure it out whether it's secure or not. Okay, time for the feedback and questions this week. We have gotten feedback from a couple people, so we thought we would answer it. Of course, we always do that. Sometimes it takes a bit longer, depending on your place in the queue, but definitely keep sending that feedback to us at feedback@bsdnow.tv. The first we have this week is James with a question about Apple T2. Goes like this. I've been looking at getting FreeBSD to support the new Apple T2 SSD/keyboard/trackpad as Linux does. Is there someone in the US who would be interested in a summer job implementing the changes as needed or as documented in Linux code to make this work? If you know anyone interested in this job, please email, and we provide the email. Both skilled and students with a mentor wishing to try are welcome. Wow, if that's not a job offer, then I don't know what is.
Yeah, so the Apple T2 is the new kind of security sub-processor thing, and it controls access to the hard drive, the keyboard, and the trackpad. And obviously a driver would be required in order to boot FreeBSD on that hardware.
Mm-hmm. And I'm fairly sure that would be open sourced and made available to other people as well, so that the Apple can also be a BSD platform. Definitely a good initiative. That's why we mention it here. And thanks for the sponsoring of that. And if you're interested, then get in touch. We have the email in our show notes, and you can make inquiries about details. Okay, then we have Michael about Jordan's ZFS question. Yes, that's a reference to a previous episode.
Mm-hmm.
And goes like the following. Hey R, hey all. Regarding this comment a few weeks ago in episode 347.
Yeah, so that one was somebody was having trouble importing the pool, and they saw some corrupted metadata, and they were using the zpool import capital T flag to rewind to an older transaction group.
Oh, okay. So yeah, the feedback here is I sincerely hope they try to read-only import first. And yeah, that's a good first try.
Yeah, so if you are going to try any of the rewind types in ZFS, if you set the -o read-only equals on, it will allow you to import it read-only without making any changes. Whereas if you import read-write, you've now changed the file system, and it means you can't really go back forward again. So yeah, if you're going to rewind, it's usually worth trying it read-only first, because if it doesn't work, you don't want to have made things worse. You might take other recovery options off the table by making any changes. Depending now. In the case of a file system that isn't ZFS and isn't likely to be many, many terabytes. So if you have a small enough file system, what you really want to do is image the whole thing and work on a copy of it so that you can always go back to the unmodified copy. Although that can be impossible when you're talking about, half a petabyte of data or something like that. But yes, definitely a good recommendation to do the read-only mode and maybe even the -n flag and trying it that way.
Mm-hmm. Yeah, and JT notes to that is, the recovery. There is a website, ZFS-recovery. Okay, so recovery is data, and someone in the open source community should figure out how that works and make it a ZFS utility. Okay, so that pretty much
Yeah, so this is a third-party tool that does some ZFS recovery.
seems like it.
Is it a tool or a service? Looks like it's a tool.
Yeah, seems like software.
It's very interesting to see ZFS recovery tools that are written in .NET on Windows.
Maybe it was for the Windows version of ZFS, but
No, this is mostly built for things like Nexenta Store.
could be a customer thing that they wanted to have a GUI type thing. Who knows?
Interesting.
But yeah, good to know about this. And if you have a similar problem, then you can at least get some pointers where to get help. And doing another one from Rob, FreeBSD friendly registrar. Rob writes, Alan and Benedict, my current domain registrar uses Ubuntu. I'd like to switch to a registrar who uses and or supports FreeBSD or any BSD. On the FreeBSD commercial vendors page, I see Pair Networks listed as a FreeBSD user. Yet recent Netcraft reliable hosting company reports list them as using Linux. Which domain registrars are FreeBSD friendly?
The one I know of is Gandhi, the French one. They offer their deepest enterprise level discounts to FreeBSD developers and things like that. And they've used a lot of FreeBSD and ZFS. I definitely wouldn't say they use exclusively FreeBSD though, but I like their API. It works well with the acme.sh client I use for Let's Encrypt. They have a good GUI and they're not constantly trying to upsell you on things like other registrars I've used. So that's who I would recommend. But
yeah, the commercial vendors website sometimes gets a bit outdated because people can change their company's website without notifying us. And if they switch to a different operating system, that we don't get to know about this necessarily. So some of my mentees do occasional sweeps of that commercial vendor's website to just remove entries that point nowhere or the domains have expired or something. But the information in there is sometimes a bit stale, but definitely keep looking there for an idea of where you could host your little project. And if something doesn't work, then let us know and we'll remove it there or update it. So, but yeah, the recommendations Alan gave you are definitely a good start. Okay, I think that should pretty much wrap up this episode. Thank you for listening. As always, keep us updated with something that you found on BSDs or anything that's on your mind, feedback-wise, and let us know at our email address, feedback@bsdnow.tv, or check out our website, bsdnow.tv.